Alright, so let's look at the first example, tangent inverse of root 3 over 3. Same process. We know that what we're looking for is an angle, and it's the angle defined by tangent of root 3 over 3. And we need to rewrite this as its inverse. So tangent theta equals root 3 over 3. So we want to find the places on our unit circle, so find our angles where tangent is root 3 over 3. Issues, we don't have tangent labeled on our unit circle. So how do we figure this out? Well, we have to remember tangent is sine divided by cosine. So if the root 3 is on top, you need to find the place where sine has a root 3 in it, basically. So where does sine have a root 3 in it? Well, it has a root 3 when we are in this combination, right? Where cosine is 1/2, sine is root 3 over 2, because, I'll use a different color, root 3 over 2 divided by 1 over 2 . Oh, I said this all backwards. So this is a perfect time to notice about trial and error. Okay, so root 3 over 2 divided by 1/2, that is root 3 over 1. That equals root 3. That is not what we were looking for. In fact, I actually wanted the cosine to be on top. Okay, so I want the cosine to have the root 3 over 2. So let's divide these two. So sine is 1/2. Cosine is root 3 over 2. This is the one we want. This is 1 over root 3, which if you rationalize it, it's root 3 over 3. So this is the angle we want, and we want the combination of root 3 over 2 and 1/2 because we want a positive tangent. All right, so that happens at pi over 6. We know this is the right answer because it's in one of the correct quadrants, but also we're going to get tangent of root 3 over 3 whenever we have both of them being negative. So root 3 over 2 and negative 1/2. So both of them negative, we're also going to get tangent is root 3 over 3. So also at 7 pi over 6. Again, you don't have to write both options. I'm just showing that it happens multiple times and you have to choose the correct quadrant. Pi over 6. Okay. All right, let's look at the next one. Tangent inverse of 0. Okay, so remember, we're looking for the angle theta, and theta is given by tangent inverse of 0. So that means that tangent of theta equals 0. So we're trying to find the places where tangent of theta equals 0. So remember, tangent is sine over cosine. So in order for a fraction to equal 0, the numerator has to equal 0. So tangent will be 0 wherever sine is 0. That happens at 0. It also happens at pi. Only one of those is in quadrants 1 or 2 or 1 or 4. So the answer is 0. And then finally, our theta is given by tangent inverse of 1. So we want to find the angle that makes tangent theta equal 1. All right, so again, tangent is sine over cosine. If we want this fraction to equal 1, that means sine has to be the exact same as cosine. So we want to find all the places where sine is equal to cosine, happens at pi over 4, also happens at 5 pi over 4. Only one of them is in the appropriate quadrant. So we're going to go pi over 4 as our answer. Okay, so now let's talk about using our calculators. Okay, so whenever we are using our inverse trig functions, we want to make sure that our calculator is in radians, right? Our trig functions are defined either in radians or in degrees. So your answer depends on what your calculator's mode is in. All right, so for the first one, sine, and we want to find it in radians and degrees. So sine of 0.7, we want to make sure our calculator is in radians. If you don't know where to find it, just hit the mode button. Make sure radians is highlighted. All right, so sine inverse is in green above the sine symbol, so we have to do second. To do our sine inverse, put in 0.7, and we get 0.78. All right, if we wanted our answer to be an angle in degrees, we would make sure our calculator is in degree mode. All right, and then you would do the same thing, sine inverse of 0.78 is 51.26 degrees. So these should be equivalent to each other. You can always check and convert them, but these are the same. This is in degrees. So remember, radians doesn't have any units or any extra things to put on it, but if it's in degrees, we need to have our degree symbol, just so we know. All right, so let's do the same with cosine inverse. All right, so I'm going to put my calculator in radians mode. Cosine inverse of negative 0.47. That is the angle 2.06 in radians. And then if we wanted to do it in degrees, cosine inverse of negative 0.47, that's 118.03 degrees. All right, in radians, tangent inverse, so we want to do second, tangent inverse of negative 14 is negative about 1.5, negative 1.5 in radians. And then if I switch back to degrees and do tangent inverse of negative 14, that's going to give me a negative 85.91 degrees. Okay, all right, so make sure you're able to navigate your calculator for this. All right, the next thing I want to talk about are these really nice properties. So some inverse properties of our trig functions. So remember these properties. If you have inverse functions, you can compose them and get right back out what we put in. Okay, so let's look at these. So they work like you expect as long as things make sense. Okay, so if you compose sine and sine inverse of x, we should get exactly out what we put in. We should get x as our answer, but only on the interval from -1 to 1. Why is that true? Well, remember we always do the inside first, then the outside, okay? All right, so if you do your outside right here, our answer has to be in the range of sine, and the range of sine is -1 to 1. All right, so now let's look at the next one. Sine inverse of sine of x is x. All right, notice what's on the outside here. Sine inverse. That means our answer is going to be in the range of sine inverse. Okay. All right, cosine of cosine inverse of x is x, but only if x is in the range of the outside function. So this is the range of cosine. Okay, another one here, the opposite. This is only true if we're in the range of cosine inverse. All right, tangent is on the outside. Remember, the range of tangent is all real numbers, negative infinity and positive infinity. So this is the range of tangent. And here, the outside is tangent inverse, so this is the range of tangent inverse. And so I'll show you how we work this how we use these to solve problems.